Hello my friends, and welcome back. In today's live programming video, we're going to be doing some work on Komorebi, the tiling window manager for Windows, written primarily in the Rust programming language. So I have been away for a little bit. I have not written a single line of code in over a week. Gonna be a little bit rusty, but we are back on the West Coast, the best coast, and ready to write some code. While I was away, the user EBNull posted a very, very interesting issue. So EBNull, you may remember in a video from maybe a month ago, we were working on this commit to set the foreground lock timeout explicitly so that we could deprecate the alt focus hack. And I got this idea from one of EBNull's gists that was 12 years old, believe it or not. And so somehow EBNull found my reference to that gist in the commit message, as they say here, and they shared even more excellent knowledge. So currently it is very tricky to set up the positions of monitors on the virtual display surface that Windows monitors draw over, the virtual screen. And it's really, really difficult to be able to identify a device in terms of like this identifier equals this piece of hardware, right? Because like display 0, display 1, display 2 is always changing when you plug and unplug monitors, and it's just very, very tedious. But the tedium has been encapsulated in one very helpful gist, right? So the below text was written in 2019 for a multi-monitor project. I thought this would be helpful to share before it's published, which could be never. So too long didn't read. You can map GDI displays like display 1, which are dynamic on monitor add remove, to physical devices and their EDIDs, and store this mapping to restore physical monitor specific information on monitor change events. This is the API display path, which we're gonna try and follow today. And so if I bring this over, if I have a look in config komorebi.json, it's not even there. Okay, I think there is, maybe if I go here, I should have the schema docs. So one of the things that you can do right now, it's not particularly ergonomic, but you can set monitor index preferences. And the way that this works is like you set a rect, right? You set a rect, a bottom, left, right, and top. So if we look at Komorebi C state, each monitor has an ID, a name, and we're supposed to use active, oh wait, no. The generated documentation is not particularly clear here. We need to get better ones, but here you can put, I think it's the size, right? So you can put the size rect for each monitor here. Oh my god, what is wrong with Windows Terminal? All right, so let's get these two open so we can show this here. All right, so my display 1 has this size. It starts at 0, 0, goes to these coordinates at the bottom and the right. And display 2 starts here, so left is here, top is minus, so it goes higher because it's a vertical monitor. And you can take these values and you can set a mapping, right? So if you see a display with this size rect, put it in position 1 of this elements array, or put it in position 2, or whatever, right? And like, it's all right, but wouldn't it be great to say, hey, here is an EDID, a hardware identifier for this monitor, and I want this monitor to always be in, you know, position 0, position 1, position 2 in the monitors list. Yeah, so that's kind of what I'm gonna try and do today. I'm not sure how far I'm gonna get. And what the hell is going on with... oh my god. What is going on with the terminal today? Let's see how we go. Actually, why don't I move this here? So, let's see. Actually, before I do anything, I probably need to pull... There are some Dependabot things that got merged, including a... there was a security-related one on lib unsafe YAML that I remember merging earlier. Anyway, so enum display devices. So where? Huh, I'm not doing that anywhere, it seems. Let's just go into, I think this is in the Windows callbacks, where I get valid display monitors. I do enum display monitor. So I'm not doing enum display devices anywhere. Okay, so let's look up this Windows API call. And why is this different? So let's look up also enum display monitor. Monitors. This is devices, this is monitors. This returns HDC, LPC rect, monitor enum proc, and lparam. This is LPC stir, dword, pdisplay device A, and dword. Okay, this is gonna be interesting. So I wonder what this calls. So this calls monitor info wide. Okay. Oh, so this is actually quite a big change. Or is it? Because we do this. So what is EDD get device interface name? That's from enum display devices. Yeah, when you get this far down in the stack, it's just like you get hit with so much technical debt. It's insane how any of this even runs, right? So I guess we're gonna do enum display devices. It's gonna take a proc. Oh, it doesn't take a proc. Okay. A pointer to the device name. If null, function returns information for the display adapters on the machine based on IDEV_num. An index value that specifies the display device of interest. The operating system identifies each display device in the current session with an index value. The index values are consecutive integers starting at 0. If the current session has 3, you'd have 0, 1, and 2. A pointer to a display device structure that receives information about the display device specified. Okay, so we need to initialize that. A pointer to the device name. Where do you get the pointer to the device name? Yeah, it's funny, I don't even know where to start. So we have God damn it, I feel so dumb. Alright, so get monitor info, get physical monitors from H monitor. So let's see, get monitor info, what does that require? Okay, we store HMONs. We store HMONs, that's cool. Right, so like that's what I'm doing here. When I'm going through, this is a H monitor. Get monitor info. Okay, we're doing that. Get physical monitors from H monitor. Okay, so physical monitor array size. Get number of physical monitors from H monitor. Oof, okay. Damn, 12 minutes, I haven't even written a single line of code. Okay, so this is, we want to get the device interface name. Device interface name. Cool. Oh, you just increment it until it fails? Damn. Alright, so maybe we can actually do this in our callback loop here. Maybe, right? Because we're already going through each of these. Enum display monitor, where is this being called? Because this is what is called every time you enumerate through. Right? Load monitor information. We have a H monitor. What's HDC? Yeah, maybe it doesn't matter. Lparam is what we're passing through. Oh, okay. We'll try and do this. Get physical monitors from H monitor. So we'll go to Windows RS Docs. And yeah, let's try and do a little bit at a time. It always takes a really long time to search on here because the API surface is so insane. Right, so I guess we need this one. Oh go here. Might as well add it here next to the monitor stuff. So this is gonna like wrap that function, right? So number of physical monitors from a H monitor. This can be probably an I size. What T0 is interparam H monitor pub I size. Okay. And then we're gonna call something in an unsafe block, right? Because all of the exposed functions from Windows RS are basically unsafe. Didn't want to do that. So here we call get number of... Oh, I guess I don't have that yet. Number requires Win32 graphics GDI. That's probably what I don't have. So let's... Actually, I have both of those, bro. What's going on? Why you know? Why you know? Let me just try this. Yeah, that's kind of crazy. Why are you not picking that up? Why you no pick up? Oh. Is this an older version? Oh, do I need... Oh, okay, I see. So Win32 devices, I guess. Yeah. Huh. Interesting that it doesn't state that here. It should. So... hopefully... that should work. Let's see. There we go. Get a number of physical monitors from H monitor. And like there's a way that you do this with mutable something or other. It's like a pattern. I learned it once and I just kind of let it go until I needed it again. So I think it's something like this, right? You declare a U32 with a default value, and then you use the pointer address of mutable to pass it through in the unsafe block, I think. So this is gonna be num of physical monitors, and this is going to be an out thing, right? So we're going to return actually a U size, U32. We're going to return an unsigned 32-bit integer. So we pass through the H monitor, we'll wrap that, and we do standard pointer address of mutable num of physical monitors. Right? Found result. Nothing. And then we return this as okay. Alright, so let's get bacon going on the side so that we can see if we're doing anything silly that we shouldn't be. Alright, so we've got number of physical monitors. That's stage 1. So now we can call get physical monitors from H monitor, or at least we can define it. Get physical monitors from H monitor. And here again, we're giving a H monitor handle, and then we can that's in. So, all right, we're gonna say is self number of physical monitors. We pass through the H monitor and like it returns something, right? So that's how we have the number. Then in our unsafe block, we will call get physical monitors from H monitor, right? I think that part makes sense. And then we have slightly different we have an LP physical monitor array, which I think in most cases is only going to be one, but whatever, you know. Oh, wait, you don't take the... Hang on. So... Actually, I don't need to do that. I can just pass a mutable vec. Let monitors equals... Let mute monitors equals vec with capacity and it is going to be of type physical monitor. Something like this. And that is what we pass here. So I just want to see where else I've passed a vec. So I think we have to do something like this. Actually, maybe not. Let's just try not to be too clever. Mute monitors. How about that? I do as you size there. Alright, this is kinda getting there. So why don't we see if we can run this much now and just see what the output of that is. And so actually we want this to be a result of physical monitor. Monitors. Oh, a result of a vec of physical monitor. Man, I think I might just... Alright, you know what? I gotta stop second guessing myself all the time. So, let's... You know, we get to the point where we do... On startup, we do... this, we have a monitor... And then we get the H monitor, right? So let's do Windows API, physical monitors, H monitor.0, let phys equals that, and let's just debug it, right? Let's just debug it and see what happens. So stop. Cargo run Komorebi. Actually, I think that's fine. So I expect to see some debug output if all is well. But I think we're gonna have to do this a little bit differently with enum display devices. Because it can't be called in a loop, you gotta call it for each one, so I think we have to read... Bruh. Cannot be formatted. Be for real. Of course you are for real. So let's, physical monitor description, and that's a handle, and I don't think I need to do any of this. Alright. That was silly. Alright, so let's try something a little different. Right, we're gonna get all the monitor information. We get monitors in here, and then we'll do for monitor and monitors. At this point, we have all the monitors, right? And we'll do an OK here. Let's just do a Komorebi C start so that I can have some tiling like a sane person. Get all the elements. Okay, so we can try to enum display devices. Enum display devices. And so we'll pass a null here. We'll use enumerate here, index monitor, and then we can pass through that index there. We'll get a display device. But wait, isn't that... I feel like I'm just running around in circles. Windows RS docs. From H monitor, there's one. And that's the same thing. God damn it, that's the same thing. Let's also look for, once again, oh, okay, so this one is gonna return this. Okay, so this is subtly different. So this is actually the one that we need to work on. Enum display devices. helps if I can type correctly. Yeah, okay, so we'll do enum display devices. Yeah, I guess we didn't really need these, but it was good practice for plumbing through operating system calls. Enum display devices. P0 is into param PC stir, which can be null, I think. So let's do LP, let LP device equals LP piece. What's the type? PCSTR, null. Right. And then this is going to be index U32. DW flags. Is going to, I know, so this is one thing that really irritates me, is that the parameters are not like ordered, like all of the inputs and then all of the outputs, or all of the inputs first and then all of the inputs. Like they're jumbled. Very frustrating. Anyway, we'll get this one here. Let DW flags equals just this. And we need, this is our out, so we need to pass this in the way that it is expected here. So display device A, let display device equals display where do I get that from? Graphics GDI Windows Win32 graphics GDI display device. Yo, what the hell? Why can I not instantiate this struct? Huh? Display device. Yo, I just saw it. Right, so where is this coming from? Display device A. It's in there. It's in there, and it's public. And it's public. So why can I not reference it? Oh, maybe that's why. Maybe that's why. God damn it. I'm such a dummy sometimes. So it is there. Display device A. Let display device equals default. And this is going to be mutable. Okay. Still not sure what my return type is going to be, but I guess we want this. Yeah. Where'd I go? Where did I go? Here I am. So this is going to be display device A is going to be the return type. And then we call enum display devices A. Okay, here we are. So we're gonna pass in LP device. We're gonna pass in index. We're gonna pass in display device. I'm probably gonna have to do some casting. And we're gonna pass in DW flags. Right. That's good. And then display device. So let's get bacon running. Expected mute display. Can I do this? As mute. Can I do that? No. I do not want to return a vec in this case. I don't need to process the bool, or do I? Consider borrowing. Does that work? How do I process bool? I forgot. I think I need to process it with OK. How about that? Okay, and now we have a bunch of imports that we didn't even want in the first place. Cool, so let's go to line 243. And now we can call self and enumerate display devices on index as U32. If led OK device. Then let's just kind of like debug all of these device ID, device key, device string, device name, device cb, and device state. Flag. Alright, let's just debug it all out and see how that works out for us. Hopefully it doesn't all fall over. And it's all zeros. It's all zeros. That's a lot of zeros. Did I get anything besides zeros? I did not. Well, I mean, it didn't fail. But that's definitely not what I would have hoped for as the output. Oh, I need to set... God damn it. I bet this doesn't do it, does it? Memory zeroed. Okay, display device dot CB. I think CB I have used elsewhere. Yeah, this. Something like this. Equals U32 try from standard mem size of okay, and the size of is display device A. Alright, let's try that once more. Oh, okay, here we go. We got something besides 0 in some of these. Hell yeah. Hell yeah. I have no idea what these mean, but I got some digits. I'm happy with that. I'm hella happy with that. Sweet. I think there's something where you like you decode these. I've decoded them before, but it's just been such a long time. Monitor info X. Nah, wasn't there. Ooh, maybe it's this from wide. Yeah, I think it's this. So it's OS string from wide. So let's do a little something here. So we're gonna take this from device. I think it's device name. U832 OS string U1632. Oh no, you can't do that. It has to be a U16. How do I convert this? From God damn it. Well, okay, we got some stuff, right? We got some stuff. I'm very happy that we have stuff. So we don't need the CB there. Let's go back to what EBNull was talking about. So get device interface name. So setup DI get class devs X. Windows RS. Docs. This is it, man. You know, you just gotta, even when you don't know how to do stuff, you gotta try and do it. You just gotta try and do it. What the hell is this function header? Oh my god. Alright. What the hell is this even? Okay, so this is optional. I mean, they're all optional, right? So GUID dev interface monitor, nothing 0. So this is what we need. I'm sure this is probably a constant. It is. So constant null, like null. And then that's the fourth argument, which is the flag. It returns devices that support device interfaces for the specified device interface classes. Okay. Interface detail. Device info. It's like eventually we're getting here, right? Eventually we want to get here. Why are there so many of these? Looks like they're all in the same spot. So we get the device info data. Okay. And that returns EDID bytes. Reg key, get binary value for EDID. Maybe I should read the whole thing, maybe that would help. To expand more on setup DI and devices in Windows, we can look into how devices on Windows work. In the olden days, each device driver would explicitly register a device object name that could link their device object directly to user mode via create file. Plug and play and the dynamic appearance-disappearance of devices mostly broke this, except for very old things. The new way to expose drivers is via a DIC. Each driver registers an instance. The ones we're interested in being dev instance monitor. It would probably be best to rewrite this code starting... Yeah, I definitely should have read this first. There is also... the display adapter representing graphics cards, but that's less important. What you think of as a device is actually a device instance. So it's device instance IDs that uniquely identify pieces of hardware. A device refers to the software that handles instances of a type of a device, so a device is really a device driver. Okay. A display adapter, these are the actual graphics cards / drivers. These register device interfaces of a type. Virtual monitors, okay, these are not physical monitors, these are virtual monitors. This is kind of what we've been dealing with. And then the physical monitors are the GDI display devices or the DXVA physical monitors. These are, but unfortunately these are represented differently depending on which subsystem you're talking to. GDI doesn't really care much about these DirectX. Oh, these object names are typically things like, yeah, these appear to be stable for the duration of the logon session, but unstable across reboots. So what is stable between reboots? How do we actually get the name of the monitors? The EDID is the stable thing, and it just so happens to contain the name of the monitors, Joy. So how do we get that? Well, that's what EDD get device interface name escape hatch is for. Using it, we can get the physical monitor hardware device as enumerated by the plug-and-play system. Of course, that's not a stable identifier either. If you swap physical plug, once we get the setup DI name, we can query the private registry key, which just so happens to have a reg binary key named EDID containing, you guessed it, the EDID. One could match on the entire EDID for a stable identifier, but that's a lot to remember. Luckily, the EDID has fields for this. In short, I chose to make monitor name, PNP name, monitor serial number, the unique identifier. This provides us with what I'd call the logical monitor identity, such as... Okay. So the monitor name is which bit was the monitor name from? Oh my god, I don't even know. Is this a build function, by the way? Like, maybe I can just look this up. EDID registry binary value. Oh wow, this is old as hell. 12 years ago again. Right, okay, I kind of see why this is getting at now. So you go into here, you have some unique ID. So, oh, you need to... God damn it, that's what you need to do. Okay, so if I do reg edit, and if I try and look this up, so H key local user, oh, local machine. Okay, we go into system, current control set, enum, display, where are you, display? Okay, yeah, I got a Dell monitor, I got an Acer monitor being the main one. Some unique ID, device parameters, EDID, ooh, okay. Like, is this the same? Why are there 3 of them? Why the frick are there 3 of them? God damn it. God damn you, Windows. This is literally so freaking easy on Linux. Why the hell is this like this? Like, oh my god, is this crashed now? Of course it's crashed, because Windows. Because freaking Windows. Okay, so I know we gotta look stuff up. And like, I wonder if I can shortcut this, right? Because like, I'm just trying to think about how to design this. So maybe we can have a command that prints out all of the EDIDs and shows the path that they came from, and then let the user put that in. But I mean, ideally it would be so great to be able to get the display name, have that there, and have the EDID, and then just refer. Oh my God's sake. All right, so I need to take a closer look at the output from this. So device name, device string, what is this returning? So, okay. I wanna convert these, right? How do I convert Rust convert U8 128 to string? String from UTF-8. Let's do that. String from... Stop this going crazy for a second. String from... Alright, that's fine. Device.device. Does that work? Who knows? Most likely not. We got ID, we got name, we got device key. We got device ID key, we got the stir, we got device name, right? And this one I think needs to be from I don't think this one's gonna work. We'll do it anyway. U8. Oh, that's from... Wait, they're all U8, aren't they? They're just different sizes. Okay, yeah, still from UTF-8. That's legit. And... oh wait, that's it. So instead of all this, let's do ID, key, stir, name. And let's see what we get. Ooh, alrighty. That looks pretty cool. That one didn't work. No worries. This one is a registry key. This one is a stir. Okay, so ID doesn't work. Key works. Stir works. Name works. So why don't we see if this doesn't crash. Okay, so current machine, system, current control set, control, I think it's video, D33 000. Session, volatile settings. Okay, so this is the driver stuff I was talking about, right? Yeah. Okay, that much makes sense. So this is the stuff that I got. So I got the stir. ID, I don't have anything. And the name we have display 1, and I guess the next one is display 2. Right. And they're both under D33. Video. Okay, so we want to navigate from there to what was it again? To enum display. Right, so like, god damn it. Yeah. So we need a different way of getting this. Like, I don't know if there's even a way to search in the registry. It's so crazy, man. Like, Windows lives off this monstrosity. Windows really does live off of this monstrosity that is the registry. Where are we going? We're going to video. Yeah, like there's we got D33 in here. We got this. And like, see, I don't see the reference to here, in here to the type of monitor that's connected. Alright, but we figured out how to get strings, which is nice. Which is definitely nice, so we go back a little more. Got the device interface name. Turns out that the EDID is the stable thing. Using it, we can get the physical monitor hardware device. Of course, that's not a stable identifier either. Once we get the setup DI name, we can query the private registry key. Okay, so we need the setup DI, which is where we're heading next. Let's do it. Let's do it. Windows API. Enum display devices. So we'll call this setup DI get class dev X. That's what we're gonna do, right? I'm not sure what the result is going to be for now. I'm not even sure what we're going to pass. Yeah, like we can just return nothing there. We got this, we got Windows RS docs, we got this. Damn, this is probably on track to be the longest programming video I've done. So here we have setup di get class dev xa, which of course is not available. Is this? It's gated behind a feature, I guess. Where's that adding it? It's not adding it. No, okay, it's adding them here. Alright, fine. Okay, so now we have that. And we're gonna pass we're gonna pass some GUID dev interface monitor. Cool. I think this is gonna be a none as well. So we have an option, enumerators P0, P1, P2, P3, oh my god. Okay, so P0 is, it's gonna be null, okay. That's the one, right? Okay, so we'll call this enumerator just to keep the nomenclature the same. Why isn't this working? Expected const. How do I make this const? Let class GUID equals as const. As const what? That's unfortunately not working either. Okay, You get rid of this and this and this. Multiple arguments are missing, so we'll get through the rest of the arguments. So this can be 0 HWND parent. Wrap that in. Flags are gonna be DIGCF device interface. Takes 7 freaking arguments? Dude, chill. Device info set. Is that in this? So I'm guessing the rest of those are optional. HDEV info 0. We'll just 0 them out, right? Or just use defaults. P3 is going to be machine name. And reserve is going to be none. Let's try this. Suggestion from Clippy. Wow, that is insane. That is actually freaking insane. So this returns, what the hell does this return? HDEV info. Oh wait, is that the input? So we got that, we got the enumerator, we got the parent, got the flag. Oh, this one actually has a return type. Damn, that's crazy. Damn, that's actually crazy. HDEV info. So maybe we can do here, okay. Process. Oh no, maybe we have to do a straight process. Yeah. Wow, I have no idea what this is doing, but we're gonna try it out. We are definitely gonna try it out. So we can inline this, and then we can probably inline that as well, I think. Yeah, inlined. It would help if I called this from somewhere, I imagine. So still not quite sure what this is doing. So is this gonna get all of them? Let's see. And so we can just set up let stuff. I don't even know what the stuff is. Hey. Don't pull that funny business on me. How can this only be an eye size? Returns a handle to a device information set. Such a convoluted API. Oh my god. So then I gotta call this. At a certain point, I'm gonna have to say this is not worth it. Oh my god. Oh my god. Out optional. What's this about? So set up the enum device info. I'm sure you need some input. Oh, okay. Oh, so you need to get the frickin' device info set. Oh, you just need the handle. You just need the handle. We have the handle. We don't know which handle. Oh my god, dude, I'm so confused. Maybe I can just do this one. But we're only getting one. We're only getting one. Okay, so I've done this, got this bit, and that got me like halfway there. It got me to the video driver bit, right? But I need to get that name. And oh, it doesn't show me that type. Or does it? All right, let's try going one more level deeper into this D word. Maybe if I ask really, really nicely, EB no will open a PR. So that I don't have to sit here looking like an idiot who has no idea what he's doing. So, okay, so what I don't get, right, is like this doesn't take anything. And if you have more than one monitor, like how do you know? A device information set that contains requested device information elements for a local. So is this returning more than one? Like this is the bit that I'm not getting. So it's returning a device information set. Okay, so it's returning like for everything, right? It's returning for everything. Cool. Setup DI enum device info. That's the one. That's not the one. Oh, it is. But in order to... Do I need the interface detail, right? Do I need the interface detail? Right, I do need that so that I can tell how many members are in the set. Interface detail. Not that. Not that. Not that. Not that. Interface detail. Alright, let's try it. Let's just write it and call it. Don't have to understand it, just gotta write it and frickin' call it. Unless IntelliJ decides to crash. I swear to God, if IntelliJ crashes, this session is over. Oh. Okay, so this stuff is actually just not something that we care about right in this instance. Why is this not okay? Oh, this is dupe. Okay. It's gonna be setup di get device interface detail. And this... To do this, we're gonna do self setup di get class devs x, right? And that gives us the HDV info, and that is what we can pass here. So setup di get device interface detail. Cool. Right, so we got HDEV info coming in. I need the Rust docs for this as well. Get info. Oh, dude, it's not gonna come up like that, is it? Search for this. SP interface data. a pointer of this type is typically returned. So wait, which one are we doing first? Yeah, class devs, okay. A pointer of this type is typically returned by enum device interfaces. But do I need it? Okay. Do I need it? I don't know. Well, it's not optional, which specifies the interface in device info set for which interface data. So this, I think we know this is monitor, right? Can be used to get just device info data. Alright, I think I'm gonna give up for today. Yeah, this is way too much. I can't even, I'm afraid I cannot. I'm really stuck. I'm gonna ask on the issue for some more guidance, maybe push this to branch. This is very difficult. This is very difficult indeed. If you made it all the way through to the end of this 1 hour 30-minute video, thank you so much. Let's give a shout out to the sponsors. It's been a minute, right? It has been a minute. Potentially private sponsor number 1, 2, and 3. Thank you all very much for your support. EFL1P, Solomon, Julian, Evan, Maxwell, Red Lobster, Darian, Leandro, Alex, Kwang, Surefire, Michael, Mikal, sorry, I'm not getting that right, Michael, Pavel, and Hisayuki. My friends, thank you all so much for your support. If you too would like to support the continuation of this project, head on over to the sponsor page. You can be a one-time sponsor, monthly sponsor, whatever you would like. Anything is appreciated, even if it's $1 a month. If however you are not in a position to be a sponsor, head on over. You're probably already there right now. Hit subscribe on the YouTube channel. We finally made it to 1,000 subscribers, and that is incredible. That is more subscribers than I ever thought I would ever get in the entirety of the lifetime of this channel when I started. Absolutely insane. We have some basic monetization available now in the form of tips, but we do still need, I believe, another 600 or 700 watch hours to be eligible for ad revenue. If you like these videos, share them, watch them. If you find them relaxing, play them in the background while you're doing other stuff. Yeah, hit subscribe. I would appreciate it very much. That is, oh my god, I'm so freaking drained. This is like the single most draining development session I have had in as long as I can remember. So thanks for sticking with me all the way through it. I probably should have picked something simpler for my first live programming session back after a long break, but it is what it is. I hope that whatever you all do today, you have a great day. Free Palestine, and I'll see you all back here next time.